In this segment, we'll look at sigma notation. So you may or may not have seen this in high school, and basically sigma notation is a compact way to write an instruction to add a whole bunch of things up. And the sigma will refer to the Greek letter capital sigma, which is what we use for this notation. So the idea behind this is that if I wanted to say add up a whole bunch of stuff, like something like this, this takes quite a bit of space to write, and let's say that I were going to add up 10,000 of these fractions, then I certainly wouldn't want to actually list out all 10,000 of them. So instead, we're going to use a different notation. So let me just write what it would be for this this case here, and then well, we'll write it for, say, the first 4 of them. So let me actually erase this stuff here. So if I just added up these 4, then this is what the sigma notation would look like for it. So I've got a sigma, and the sigma just means to add stuff up. And then basically I'm going to count over some letter, and typically we use the letter I or sometimes N. And in this case I'm going to run I from 1 up to 4, and that should make sense because I'm going to add up 4 different things. So starting at 1, ending at 4, I'm going to do 4 things. And then I need a formula, and the formula that's going to go right here is going to describe each of these numbers here in terms of I. So if I look at the first one here, 1/2, well, and this one's 1/4 and 1/8 and so on. So we should probably guess that 1/2 is involved here somewhere. But notice that this 1/4 is actually 1/2 squared. The 1/8 is 1/2 cubed. The 16th is 1/2 to the 4th. And then the half is just a half to the 1st. So if my formula is 1/2 to the I, then when I equals 1, I get the 1/2. When I equals 2, I get the 1/4. When I equals 3, I get the 1/8. And when I equals 4, I get the 1/16. The sigma tells me to add all this up, and then we stop when we hit I equals 4. So this would just be the first 4 of these guys. Okay, so let's just kind of rewrite this a little bit. So notice that if we have I equaling 1, then 1/2 to the I equals 1/2. I equals 2. We get 1/4, but that's really 1/2 squared. Okay, and then we're just going to keep doing this process. So I equals 3. We'll get 1/2 cubed, and that's 1/8. Sorry, I keep messing up the equal signs. And then finally, for this example, we'll stop at 4 because I just want to do the first 4 terms. And so we'll have 1/2 to the 4th, and that is 1/16. And then the sigma part just says to add all of these up, and so what we get is 1/2 plus 1/4 plus 1/8, I'm sorry, do it in order, plus 1/16. Now, what this actually equals, I mean, we could manually just, either with a calculator or doing common denominators or something, add up what these fractions actually sum to. But what we're really interested in right now is just how can we write this notation, this list of things to be added together in a more compact way. And we'll talk about in class why we actually care about doing this. So it's not just, we're not just doing this for fun. Okay, now we could do this sort of in reverse. So, well, actually, we'll do one more sort of example similar to this. So let's look at, before we do the reverse version, let's look at this notation here. So we'll start with the sigma notation. So in the previous example, I started with the actual fractions added up, and then we determined what the notation should be for that. So here we're kind of working in reverse, that we'll start with the sigma notation, and we want to know what this actually means. Okay, so just like before, we need to think of, okay, if I equals 1, then the thing here that I'm adding up has a particular value. When I is 2, it's something else, 3, it's something else, and so on. Okay, so we're going to have 6 terms that we're going to add together. And so what I'm going to do here is put I equals 1, I equals 2, I equals 3, 4, 5, and 6. And then we'll actually add up or write what the terms are here. And then fix some of these equal signs. Yeah, so I'm going to list out the 5 terms, or 6 terms, excuse me, kind of like we did over here, but just for space reasons, I'll do it this way. Anyway, so when I equals 1, we have 6 times 1 plus 9. So I'll just write that as 6 times 1 plus 9. I equals 2, we get 6 times 2 plus 9. Then for this one, 6 times 3 plus 9, and so on. I'll just write all those. Times 5 plus 9, and then lastly, 6 times 6 plus 9. And then the sigma part tells us to add all of these things together, and then we're going to get some number. So at this point, we really just have to do a whole bunch of arithmetic. And in class, I'll show you some shortcuts for how you can actually compute this without manually adding everything up. But this isn't really all that hard to do if we just, sort of add a whole bunch of things up with a calculator. You might say, for example, notice that each term has a 9, and so how many 9s do we add up? We add up 6 of them. And then the other stuff, we're adding up 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, and then 6 times each of those things. So we could do this quick little arithmetic, and it turns out to be 180. Okay, so we've started now in sort of 2 different ways. We've started with adding up a whole bunch of terms and then writing that in sigma notation, and then sort of the reverse situation, which was here starting with the sigma notation and then figuring out what that actually means. Okay, now if you had a lot more terms to add up, like so say here in the first example we had only 4 terms, in this one there was 6 terms, it's kind of nice to be able to computationally, in some sort of quick method, check what the answer is supposed to be. And that'll be especially helpful in 2 situations. One, where there's a lot more terms to add up, and we'll deal with those. But then also ones where the numbers aren't necessarily nice fractions or nice integers like this, where there might be decimals or something. So in the next quick little segment, I'll show you how to use Wolfram Alpha or Mathematica for that matter, but I'll show you with Wolfram Alpha how to actually just compute these real quickly for the sake of checking your answer. Okay, so in this quick little segment, I'll show you how to do this computationally with Wolfram Alpha, which is a great way to check that the answers that you're getting make sense. So I've loaded here wolframalpha.com, and you can do this basically from any web browser, iPad, whatever, doesn't matter. And the search bar is basically just like what Google would look like, but you can type in here stuff that you're interested in knowing. So let's take the example from the first segment where we added up 1/2 plus 1/4 and so on. So we wrote the sigma notation for that, and unfortunately you can't really type that kind of notation here, but Wolfram Alpha is actually pretty smart, so we can sort of fake it and it'll figure it out. So I wanted to add some things up, and we started with I equals 1, and we ended up at I equals 4. And then the things we were adding together were 1/2 to the I. And so if I enter that, then what I get is the sum here. And so now we see it in the proper mathematical notation. I equals 1 to 4 of 1/2 to the I, and that's exactly what we had. And then quickly it's added up for us that it comes out to 15 over 16, or if we wanted its decimal representation, then there it is right there. So not too difficult. And then while we're at it, let's check the other one that we did. So that one was I equals 1 to 6. And then the formula that we were adding up was a little different. So it was 6i, oops, left parenthesis, 6i plus 9. And so this should give us the 180, I think it was, that we got before. So if we compute this, and then sure enough we get 180. So quick little computational way to double check that these answers make sense. And this will be more particularly useful when we're doing problems where you need to do either way more than 6 terms or the fractions are kind of messy and you want to do a reasonable decimal approximation. So quick little checking tool. Don't cheat with it. You can do everything with this, but you won't understand what any of it means. So use this tool for good, not evil.